back. Now we start problems from web work. On web work, look for section 7.3, Trigonometric Substitutions. There are 12 problems. Let's go through each one. First question, evaluate the integral using the indicated trigonometric substitution. So they have given us what trigonometric substitution is to be used. Integral 2x cubed square root 9 minus x squared dx. Use the substitution x equals 3 sine x. Now this you probably recognize by now when it is minus x squared. So it's a constant minus x squared. Then x takes some form of sign. Now what form? You take square root of the 9. Okay. In essence, you are looking for something that would make this resolvable. You see, 9 minus 9 sine squared. That's what you're looking for. Okay. So, now you notice this is an indefinite integral. So, you need to be using constant of integration. So, let's start playing. Integral 2x cubed square root 9 minus x squared dx. Set x equals 3 sine x. Then dx is 3 cosine theta. Sorry, x equals 3 sine theta. Then dx is 3 cosine theta d theta. Moreover, 9 minus x squared is 9 minus 3 sine theta squared. So that is 9 minus 9 sine squared theta. Get the 9 out. 1 minus sine squared theta. 1 minus sine squared is cosine squared. So in all, 9 minus x squared is 9 cosine squared. So if you notice, when I'm going to take square root, I'm going to get 3 cosine theta. That's the point of it. So integral 2x cubed square root 9 minus x squared dx is 2 3 sine theta squared cubed, because that's what x is, square root 9 cosine squared theta times, this was dx, that is 3 cosine theta d theta. So notice what's going to happen. 3 cube is 27. 2 times 27 times, you are going to get a 3 here, times another 3. So all of that is 486. Sine cubed theta. Square root of cosine squared is a cosine, and another cosine is cosine squared theta. So all of this simplifies to 486 sine cubed cosine squared d theta. Get the constant out. Now notice sine cubed and cosine squared. So I'll keep the cosine squared as it is. Of the 3 powers of sine, 2 powers I will keep here, 1 power I'll take over there. So sine squared can be rewritten as 1 minus cosine squared. At this point, if you notice, we can use another substitution. U is cosine theta, because then du has that sine theta d theta with a negative sign. So that's not a problem. So 1 minus u squared times u squared. All of this is negative du, so that negative comes out. So notice I can distribute the u squared. So I have this integral of u squared minus u to the power 4. Now that's straightforward. U cubed over 3, u to the 5th over 5, minus and a minus, the constant as it is. Now go back and substitute what u was. U was cosine theta. Okay, that's fantastic. But we shouldn't be stopping here because our question was in terms of x. So notice, here you know what's happening. Cosine theta is going to be square root of all this over 3 basically, right? X is 3 sine theta. You can use a right triangle, or you can use our work here, 9 minus x squared, to find out that cosine theta is square root 9 minus x squared over 3. That's all. So that's cosine. So power 3 will be power 3. So square root is power half, power 3 is power 3. So that's all we have done. Power 5 is, that should be a 5. Okay, like here, it's a 5. And then don't forget power 3 of this and power 5 of this. Okay, so all we are doing is multiplying, and this is my final answer. So that should be a power 5 like here. Okay, so that's my final answer. Let me try. I hope it's clear, right? I've simplified it, and I have tried to simplify this, and so on and so forth. So let's try to substitute. -6, 9 minus x to the power 2, and power 3 halves. Don't forget 3 halves. Place it in parentheses or braces so that you are taking power of the entire fraction, power with the entire fraction rather than part of it. 2 times 9 minus x to the power 2 power 5 halves, and all of this over 5. And don't forget constant of integration. So let's read, let's see. Correct. Next problem. Evaluate the integral. So you notice it's a plus, so that's going to be some kind of tan. What kind of tan? Square root of 9, so 3 tan theta. So you want to integrate this. So let's go. Integral 9x cubed over square root x squared plus 9 dx. X is 3 tan theta. Therefore, dx is 3 secant squared d theta. Moreover, what happens to the square root? Square root of x squared plus 9 is square root of 9 tan squared theta plus 9. Get the 9 common. Tan squared plus 1 is secant squared, but square root gives me secant. So the whole point of this expression, 3 secant theta. Therefore, this integral is integral 9 3 tan theta power 3 over all of that was 3 secant theta. Okay. Now dx is 3 secant squared theta d theta. So having written everything down, you can cancel these. You can cancel one of the secants. Now here 9 times 3 to the power 3. Okay, so that's 27 times 9, 343, 10 to the power 3. So you have all of this here. So that's an odd power. So take one of the tan away, you have secant tan. So that's tan squared. So notice secant tan is derivative of secant. So why not rewrite tan squared as secant squared minus 1. So set this to be u, secant to be u, du is secant tan d theta. So u squared minus 1, all of this is du. When you integrate it, don't forget the constant, keep it here. That gives me u cubed over 3. This gives me a u and a constant of integration. U is secant theta. So u cubed is secant cubed theta. U is secant theta. Now go back. Remember what secant theta was. Secant theta is this expression over 3. And that's what we have done. So all of this is 243 times this expression over 3 power 3. And there is a 3 here in the bottom. All that resolves to 81. So make sure your calculations are correct. Likewise here, plus constant. So you can simplify this, by the way. 81 goes here 3 times. And 3 goes in here 81 times. So we got rid of the denominators and we have a neat solution at the end. So let me put it in. There. 3x squared plus, plus 9 power 3 halves minus 81 So that's power half. You may use this approach or SQRT, x squared plus 9 plus constant of integration. Okay. All right, so let's check. It's correct. Okay, let's try one more problem. Integral 9 over x squared, square root x squared minus 9. So this x squared is first and there is a minus, so that's some kind of secant. What kind? Square root of this. That's a 3. All right, so let's try one more. So integral 9 over x squared square root x cubed minus 9. X equals 3 secant theta. So dx will be 3 secant theta tan theta d theta. Moreover, what happens to the square root? Square root x squared minus 9 is square root 9 secant squared minus 9. 9 is common. Secant squared minus 1 is tan squared. So square root gives you 3 tan. So this integral now is 9 over x squared square root x squared minus 9 dx. That is square root 9 over x squared itself is 9 secant squared. And this square root expression we just calculated was 3 tan. So 9's cancel. Oh, by the way, dx is all of this. So 9's cancel, 3 tans cancel, 1 of the secants cancel. So all you're going to have is 1 over secant. Well, 1 over secant is cosine. Integral of cosine is simply sine. Now x is 3 secant. So cosine is, you see, secant is 1 over cosine. So cosine is 3 over x. Now you can use triangle, right triangle, and you can see that sine theta is all of this. In other words, this expression is simply square root. You might want to see clearly. Let me zoom in. So square root x squared minus 9 over, whoops, I hit enter it seems, over x plus a constant of integration. Check. Correct. Okay. So we'll continue until in the next video.